Hello, the group is conformed by Camila, Coneo, Pimienta, Sofia, Pedraza, Chirolla, and Yeni, Marcela, Moreno. The article found is Thermal and Mechanical Properties of Grooving Glass Fiber Reinforced Epoxy Composites with Carbon Nanotubes Ground in situ. Okay, the main objective of the article is to improve toughness by implementing the ground of carbon nanotubes on the surface of the fiberglass. As a procedure, first, the grooving glass fibers were uniformly coated with an iron acetate catalyst. Second, CNT were ground on the fibers using the chemical vapor deposition technique. Finally, the respective tests were carried out. After testing, the microstructure observed on the surface is this, where you can see that the CNT grew uniformly on the surface of the fiber. Then, my partner Sofia Pedraza will explain the thermogravimetric analysis.
Okay, for the thermal analysis, we can see that the researchers put in one graph the TGA and DTG curves. From the weighting loss curves, it is found that the thermal degradation of knit woven glass fiber reinforced started early than the CNT grow woven glass fiber epoxy composite. From the differential thermal gravimetry of the TGA, it is found that the peak weight loss in the CNT grow glass fiber reinforced composite occur at approximately 5 Celsius degree higher temperature than in the knit composite. The DTG plots also represent that the weighting loss peak at 3 temperatures in the knit system. Multiple peaks were also found in the DTG plot of knit glass system. Elsewhere, the peak degradation of CNT grow woven glass fiber composites has found to have only at the 1 temperature, and this is 355. These observations indicate that the CNT grow woven glass fiber composites has a stable degradation and reasonably higher temperature than the knit woven glass fiber composite. And the next is the DSC diagram.
The DSC doesn't show a great change in the heat flux profile between the knit one and the CNT, but there is a greater increase in the TG of the knit one compared to the woven glass fiber ground in CNT. These results show that it's necessary a small amount of CNT in the compound to make changes in the glass transition.
In the graph, we can see the flexural analysis of knit and carbon nanotubes. Woven glass fiber composite. It is found out that the flexural strain of 0.62 with percent carbon nanotube grown woven glass composite is around 526 megapascals, which is around 60% higher compared to the knit, which is around 451 megapascals. This increase in flexural strain indicates the improvement in the mechanical properties of carbon nanotubes grown woven glass composite due to the increase in the frictional resistance in the fiber matrix interface. Also, the flexural modulus of the carbon nanotube grown composite increased, and this indicates the increase in the interfacial strength between fiber matrix. In the article, it says that the layer with grown carbon nanotube creates a bridging effect between the fibers and the matrix that helps restrict the sliding of the layers under tension or compression and thus increase flexural strength. So, we can infer that the failure strain of the carbon nanotube grown woven glass composite also increased if we compare it with the knit one. On the other hand, the toughness that we can analyze it as the area under the stress-strain graph, we can see that the area of the carbon nanotube grown woven glass composite is bigger. The value reported was 984.3 kilojoules per cubic meter, and for the need was 753.7 kilojoules per cubic meter. Also, the failure strain increased, which indicates an overall improvement in ductility and failure strength. Therefore, the results suggest that controlled growth of carbon nanotubes reduce the failure of glass fiber reinforced polymer composite.